All right. On the last lesson, we talked about coordinate planes and plotting points and finding the coordinates of points and which quadrants those points lie in. Today, for 5.2, we're going to be interpreting graphs. Now, as our lessons go on, our graphs and our coordinate planes are going to merge together. So they start us off with giving us them separate, and then we will put them together. So if you look in our book, it says, you can use a graph to show the relationship between speed and time and distance, or speed and distance. The graph at right shows the varying speeds at which Emma exercises her horse, and the horse walks at a constant speed for the first 10 minutes. Its speed increases over the next 7 minutes, and then it gallops at a constant rate for 20 minutes. Then it slows down over the next 3 minutes, and then walks at a constant pace for 10 minutes. Let's draw that out. So, first, we're going to draw just quadrant 1. So, on our y-axis, we have speed, and it looks like it is numbered in 5s, so 5, 10, oops, gotta do the same distance. So let's do 5, 10, 15, 20, 25, 30. And then over here, we have time. And we'll do the same. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So 5, 10, 20, 30, 40, 50. 10, 20, 30, 40. Okay. So, the first thing she says is, the horse walks at a constant speed for 10 minutes. So, 10 minutes, she walks at a constant speed. It doesn't give us an exact speed, but at the graph, it looks like it's just a little under this 5. And so we draw a line for 10 minutes. Constant. It was constant for 10 minutes. So at 10 minutes, something changes, and it says its speed increases over the next 7 minutes. Okay. So it looks like it goes up to, let's see, 7 minutes is going to be about here, and it goes up to 25 in that 7 minutes. And so for 7 minutes, her speed increases to this point. Okay? Then it stays constant for 20 minutes. So it's going to stay at this rate for 20 minutes. So we are here at 17. So we would go to 27 and then 37. Constant for 20 minutes. Then pretty quickly, so in 3 minutes, it drops back down to the speed we were prior. And stays there for another 10 minutes. Okay? So, this little graph is a representation of our horse's speed over a matter of 50 minutes. So, they're going to give us 3 more little graphs. And we are going to interpret which one best shows the situation they give us. So, the first one is this. We have time and distance. And the time and distance looks like this. It looks like a triangle. Okay, this is graph A. the next one we have is graph B. We have the same coordinates, and it looks more like this. Okay, so that's graph B, and graph C gives us something where we start up at the top, we come down, we plateau, and we come back down. And this is graph C. Okay, so I'm going to read the situation that they give us in the book, and then we're going to talk about why a certain graph meets that situation. So it says that Jenny leaves home and drives to the beach. She stays at the beach all day before driving back. Which graph best shows the situation? Okay, so she drives straight to the beach and then she drives back. So, this point where our distance, not time, meet, is home. She starts here. Now, let's start with graph B. It says that she drives to the beach. She stays on the beach all day. So she's not leaving, her distance is not going anywhere, and then she comes home. Graph B seems to fit that scenario. Let's look at graph A. Graph A would be she drove to the beach and then came straight back home. There was no staying in graph A. In graph C, she starts at the beach because home is down here. So she starts at the beach, comes here, stays there for a certain amount of time, and then comes home. So, the graph that best fits our scenario is graph B. She drives to the beach, she stays at the beach all day, and then she drives home. Okay. So, as you can see, her distance from home increases over amount of time until she gets to the beach. And then her distance is not going to change. She's not leaving the beach for this entire amount of time. And of course, then her distance will get closer to home until she is home. Okay, so B is our answer. Now, for this assignment, we are going to be interpreting a lot of these different graphs. So, there's not very many problems that you're going to have to do. So you're going to have examples of graphs with a situation. You pick the graph that best fits, like what we just did. And then you're going to be given a situation and you have to draw what the graph would look like. Okay, so let's practice that with one of the problems from the book. Okay. So, we're just going to look at number 4 together, okay? We'll do that together, and then let's talk about number 4 together. That way you have a better idea of what you're doing on some of these other problems. Okay, so it says, on her way home to the grocery store, a 6-mile trip, Veronica stopped at the gas station to buy gas. After filling her tank, she continued to the grocery store. She then returned home after shopping. Sketch a graph to show the distance from Veronica's home compared to time. Okay, so we know that our y-axis is going to be distance from home. And our x-axis is going to be time. Okay, so if we read it, it says she starts at home. She's taken a 6-mile trip. She drives a little bit, drive, and then she stops. She fills up gas. takes a little bit of time. She stops, and she continues on to the grocery store. Well, we don't know how long she stays at the grocery store, but it usually takes a little bit longer than getting gas. So we can go out to there, and then she comes back home with no other stops. Okay, so leaves her house, goes to the gas station. She is not moving, but time is still passing. So we go over on the time, but not up and down from our distance. Then we drive all the way up to the grocery store. Again, the distance is not changing, but we're still progressing through time. And then we drive home. Okay, so this is how you solve those problems. You're not going to have very many problems on this assignment, but they are going to take a little longer because you will have to graph some of your answers. All right, if you don't have any questions, you can get started on your work. Otherwise, raise your hand and I'll come and help you.